hope everyone is doing well because I'm also fine. So in this lesson, guys, what I'll be doing, I'll be touching a hyperbola function. And a hyperbola function, guys, it goes in two pairs. For you to see that thing, it goes in two pairs. Just notice from that h there. Do you see the h there? The h, guys, it will go with those two pairs, meaning that it will be having two pieces. So just like this thing there, it's a hyperbola, this it's a hyperbola, and now the equation, guys, of a hyperbola, it is this one. Do you see this equation? This equation, guys, it represents what? The hyperbola. How do I notice this thing, it's a hyperbola? I notice by the denominator x there. If I see the denominator x, all the time, if you see a denominator as x, just know that function there, it's a what? It's a hyperbola. And now from this equation, you should understand that a, it represents the gradient. And the gradient, guys, is the one that can change the what? The shape of a graph. It can change it like this or like that there. If the gradient, guys, it's positive, it means that our shape will be like this there. But if the gradient, guys, it's negative, it means our shape, guys, will be like that there. Do you see? So how do I notice, guys, those two shapes? Let me just show you, guys, a tricky way. Here's, guys, some tricky way. I need you to understand the Cartesian plane here. Our Cartesian plane, guys, it's like this there. We got positive values there for x value, whereby here it's 0. We got positive value, but here we got some negative values for x. And here we got positive value for y there. As you go up, you got positive value for y. Here it's 0, and here you got negative value for y there. And now what I need you to understand, from the first quadrant, guys, if I can multiply those two values, I will notice that I got positive there. Then from the second quadrant, if I multiply this value, I got negative there. Because, guys, multiplying different sign, you got negative. And here, multiplying same sign, you got positive. Then coming from here, when we multiply same sign, we got positive there from the third quadrant. Then from the fourth quadrant, if we multiply different sign, we got negative. What does all this thing, guys, mean to you? This thing there, it means that here it's a negative region there. That one there, it's a negative region, this. But then now coming from this one there, this, it's a positive region, this one. Because there we got positive, this one there, it's negative. What you should understand is that if the graph there it's like this, it means that our gradient there, that's why the gradient there it's positive there, because it is on the positive region, the shape there must be like that there. But now for this one there, whereby the graph it's like this, you should understand that it is on a negative region there, as you can see. And if you can try to compare this thing from what I just show you here, it will make sense to you that, okay, this thing there, it is on a positive region, a gradient there, it's positive. This one there, it is on a negative region, a gradient there, it's negative. So please, guys, take note about this. I don't know how will you do it. You can take a screenshot, but please take note about that one. So let's talk about the dotted line there. This dotted line, guys, do you see this dotted line? We got this line like this. Do you see? So those lines, guys, they will be representing axis of symmetry and the asymptotes there. And when you will be drawing a hyperbola, you should show them all these lines. You should show them. And those lines, guys, are the ones that make this thing to be difficult to draw. Do you understand? So please, guys, understand axis of symmetry and the and the asymptotes. And those lines, guys, they will intersect all together there. That point there, it is what you call point of contact. A point of contact, guys, it is the point whereby the asymptotes, these are the asymptotes, this one. We got vertical asymptotes, horizontal asymptotes. The asymptotes, guys, and the axis of symmetry, they will intersect here. Do you see this thing? All of them, they will intersect from the point of contact there. Do you see? Then when it comes on this equation, you should understand that equation there, we can get the these two will represent the these two there, it will just represent a horizontal asymptotes there. It will represent these lines. This one, the one which are horizontal, the Q. But now the P will be representing the what? The vertical asymptotes. Let me make you to understand what are the asymptotes, guys. So the asymptotes, guys, are not that difficult, are straightforward. Something like this, them. These are the asymptotes, these are the asymptotes. But now, which one are the horizontal? Which one are the what? Are the vertical? So this, it's a line, guys, which is horizontal there. Do you see this line? How do you notice there? From H there, we should see that the horizontal line, it's like this there. Just like this there, that thing there, it's horizontal. Then coming from this one, guys, it's vertical, this one. How do you notice? You notice there, from that V there, that thing there, it's a vertical line there. So in other words, it means these will be the vertical asymptotes, but these will be horizontal asymptotes there. Do you see? But now, what are the asymptotes? Guys, asymptotes, guys, are the dotted line whereby the graph it approach, but it will never touch and it will never cross. Something like this, guys, a graph there, it will approach those lines, meaning it get closer to them. It get closer to them, but it will never touch them, and it will never do what? It will never cross them. So it will get closer there, even as well as they get closer, but it will never touch and it will never cross there. As it got closer, guys, that graph there, it is continuing until to positive infinity for the y value there. Even here, as it continue there, it will go until negative infinity for the x value there. Do you see? Even as well as here, this graph there, it will approach there, it approach until to the negative infinity for the y value, and it approaches them until to the positive infinity for the what? For the x value. Remember, these are the x, these one are the y there. Please take note about that. So the asymptotes, guys, they will just be those dotted line whereby the graph it will approach, but it will never touch and it will never cross them. Please, guys, take note about that one. So these are what you call asymptotes there. Are a dotted line where the graph it approaches, meaning that it's where the graph it get closer to them, but it will never touch and it will never cross. So just know horizontal and the vertical there. So now let's talk about what is this thing? The axis of symmetry. So coming, guys, to the axis of symmetry, if, guys, this thing, it's our graph like this. This one, guys, it's our graph there. That graph, you know, it can be like this and it can be like this, that graph there. What I need you to understand, guys, axis of symmetry, it will be the dotted line that divide that shape into two equal parts. It will divide that shape into two equal parts. It can divide it like this there into two equal parts. And at the same time, it can divide it like this there into two equal parts, just like this then. Do you see which one are the two equal parts? These parts, they are equal, these parts are equal. Then if you divide it like this, it means that these two parts are equal. Those are what you call what? The axis of symmetry, guys. Something, guys, which is symmetrical, it means that it is divided into two equal parts. Something which is symmetrical. Do you understand? So, but these two lines, guys, this according to a straight line, this thing, it's a straight line, by the way. If you can take a look, this thing there, it's like that there. In a straight line, guys, you should understand that if you say a line like this, it got a what? A negative gradient there. This thing there, it got a negative gradient. This one. But this one there, it will be having a positive gradient there. So you should know that these are the axes of symmetry with positive gradient. This one. But this one there are the axes of symmetry with negative gradient. And I will still show you guys a tricky way of you to know which one there it's positive and which one there it's negative. But so far, I hope you understood which one there are the axes of symmetry. They divide a shape into two equal parts. But then now, the asymptotes are the dotted line that the graph, it get closer to them, but it will never touch and it will never cross them. Please guys, take note about that one. So now what I will do, I'm done explaining the point of contact, where they will contact, and I'm done explaining asymptotes and the axis of symmetry. Let's talk about a domain and a range. A domain, guys, I will usually call it as dex, and the range I will usually call it as roide. The reason why this thing I call it dex, it's because a domain, guys, domain are the all x values which will be included in the graph there. Domain will be the x values which will be included in the graph there. And the range, guys, the reason why I call it as ROI, because the range are the all y values which will be included in the graph there. What I need you to understand, as I told you, that looking from the x value, that graph there, it will go to positive infinity. It continue to positive infinity, even as well as it continue to negative infinity. So what is happening there? It means our graph there will start from negative infinity for the x value, then it goes to positive infinity. But now what you should understand, our x value, guys, it won't include this line. Do you see that line? Our x value, guys, it won't touch the asymptotes there, the vertical asymptotes. And now you should understand that these are what you call a vertical asymptotes, these our P. So when you will be identifying a domain all the time, you will do something like this there. X is the element of all real numbers, meaning it will start from negative until to positive there. But X won't be equal to P. X, it's not equal to P. That P, guys, it represents the vertical asymptotes. These there. Our graph there, it won't touch the vertical asymptotes. Then coming with the range. A range, guys, if you can take a look, even as well as the range, guys, it will go to the positive infinity and it goes down there to the negative infinity. So it means the graph there will start from negative infinity, then it goes to what? To positive infinity for the y values there. But now what you should understand, a graph there, it can't touch here. It won't touch there. As it goes there, it won't touch there. Do you see this thing? That one there, it's a horizontal asymptotes. It won't touch the horizontal asymptotes. And the horizontal asymptotes, guys, according to the equation, it is Q there. That Q there will represent the horizontal asymptotes. So what I need you to understand, it means that as I will be identifying the range all the time, the range of a hyperbola, it will be y is the element of real numbers, meaning it starts from where? From negative infinity downwards until to positive infinity upwards there for the what? For the y value there. All the values there will be included, but except the q. That q there, it's a horizontal asymptotes, meaning that y it's not equal to q. Do you see this thing? Please, guys, take note about the domain and the range. And now let me tell you something, guys, when it comes to the what? To the growing of the graph. All the time, guys, when you'll be growing a function, you should know the what? The y-intercepts and the x-intercepts. The y-intercept, that's where our x value there is 0. But now the x-intercepts, that's where the y value is equal to 0 there. Do you see? But now, guys, because this thing there it's a hyperbola, you should know the y-intercept, x-intercept. At the same time, you should know the what? The asymptotes. We've got two types of asymptotes, horizontal and the vertical. A horizontal asymptotes there, it is line GR. That's line GR, that's line GR. Even as well as the what? Vertical asymptotes, it is HF. That's HF, line HF there. Do you see? But now the equation, guys, of the horizontal asymptotes, because the horizontal asymptotes, guys, something which is horizontal, it will get associated with the what? With the y values. It will just y, it's equal to q then. Y is equal to q. Even according to the equation, you can just hide this thing, meaning that y is equal to q. So something which is associated with what? With y value, it is q there. That q there, it represents the what? The horizontal asymptotes. But again, now talking about the word vertical asymptotes, a vertical asymptotes, guys, at this case there, it will get associated with the what? With the x values there. Do you see? Yeah. So meaning now, something which is associated with x, it is p. Something which is associated with x, guys, you just equate it with 0, then you solve for x. Meaning that if that thing there, it's positive there, it will become as what? As negative here. Do you see? Yeah. So please take note that vertical asymptotes will be represented by x because it will be associated with what? With x there. Meaning it will touch the x value there. So coming now and talk about the axis of symmetry with positive gradient. So the one which got positive gradient is this line. And now the one which got a negative gradient is this one. Positive, it's AB according here. That's AB. And negative gradient, it's what? It's CE. But again, now, easy way, guys, for you to know that thing there. Just understand that a straight line, it can be in 4 ways. It can be like this, or like this, or like this, or like that there. So this thing there, just take it as in it is your head. This there, it's your left hand side. This thing there, it's a right hand side. This one there, it's a system of your body. Do you see? So something like this, guys. This thing, it's something like this there. This thing, it's you, by the way. This is your head. This is a system of your body. That's left and that's positive there. Do you see? Yeah. So this thing, it's your head, left hand side, right hand side, system of your body. What does that thing mean? It means that, guys, when the gradient, if you see a horizontal line, it means that a gradient there it's 0, but if you see a diagonal line, a gradient there it's what? It's negative. Then for this one, a gradient there it's positive, but for this one, the gradient it's undefined. For a vertical line, a gradient it's undefined, guys. And now what I can do, this one, the one which is negative, it is this one there. Do you see this line? These two things, it's negative there. But the one which is positive is this one, that one there. Do you see? And for you guys, to get the equation of that thing, you come from this equation there. You only take all of this part there. Do you see? That part there, you come and take it here. The one which got positive gradient, you put positive, then you expand like this there. But the one which got negative gradient, you just put negative there, then you just expand them. Then just like that there. So for you guys to understand this thing, just watch the next lesson there, because I wasn't planning, guys, to make this thing video long, this lesson long, but it just happened, guys. It's long, but no problem, by the way. Yeah, so that is the only thing, guys, that you should understand about the what? The hyperbola. That's all. For this, they will represent axis of symmetry. Then these, you just put them inside a bracket, just like this there. When it is positive, you put positive like that. When it is negative, you put negative like that there. That's why that x it's positive. That's why x there it's negative. Yeah. So thank you guys for your time. All the best in your studies. God bless you.